All right, lesson 1.4, we're solving absolute value equations. We have talked about the graph of absolute value. As you know, it looks like a V. However, what absolute value actually is. Absolute value is the distance a number is from zero. So main point here is its distance. For example, I live in Forney and drive to Mesquite every day. I drive about 30 miles, but whenever I drive home, do I go negative 30 miles home? I don't. That's the thing about absolute value, is distance is never it's never negative, so any absolute value cannot be negative. For example, how far is 4 from 0? 1, 2, 3, 4 spaces. Negative 5, how far is negative 5 from 0? 1, 2, 3, 4, 5. So it's not ever going to be a negative number. We've got to keep this in mind when we're solving these equations. Okay, absolute value properties. Absolute value of a number is always going to have to be greater than or equal to 0. Again, greater than 0 has got to be a positive number. In the same token, the absolute value of negative a equals the absolute value of positive a. The absolute value of a negative number is the same thing as a positive number. Absolute value of a times the absolute value of b is equal to absolute value of a times b. And lastly, if we have the absolute value of a over b, that's equal to absolute value of a divided by absolute value of b. However, with this one, b cannot equal 0. Why is that? If b is 0, can you divide by a negative number? Plug it in your calculator and see. When we go about solving absolute value, okay, to solve the absolute value of ax plus b equals c when c is greater than or equal to 0. So in other words, when c is positive, this is how we go about it. It's a little mnemonic that I call ISS. It stands for isolate, separate, solve. Okay, so if c is positive, you're going to isolate it and separate. So it will look like this. ax plus b equals c, or ax plus b equals negative c. So whenever c is positive, you're going to have two different answers, a positive answer and a negative answer. You might want to make yourself a note of that. Two answers when c is positive. Okay, the other option that we have is whenever we have absolute value of ax plus b equals negative c. So basically, this is when c is less than 0, which means c is negative. Can an absolute value ever equal a negative number? Nope. So anytime you have absolute value equal to a negative number, we can't have that because absolute value is a distance, and distance can never be negative. In this case, we have no solution. Okay, let's work a few problems. Solve and graph, if possible. First problem, absolute value of x minus 4 equals 6. Okay, so the first thing that we know is that c is greater than or equal to 0 because it's positive. So here are our steps. Isolate, separate, and solve. We're isolating the absolute value bars, meaning the only thing on this side of the equation should be the absolute value bars. In this case, we are already isolated. So the isolation stage is basically the same. It's already there. Because c is positive, I know that I'm going to have two possible answers. It's positive, therefore, I have two solutions. My next step is to separate. Remember, your separate stage is where you're splitting the two equations, making one equal to positive and one equal to the negative. So our two equations are going to be x minus 4 equals 6, or x minus 4 equals negative 6. Isolating, making sure the absolute values were by themselves. Separating, making equal to one positive and one negative. The last step is to solve them. Solving meaning getting x by itself. We'll add 4 to both sides. That'll make these 4's cancel. And I have x equals 10. Same thing on this side. Got negative 4. To get rid of it, we will add 4 to both sides. And I have x equals negative 6 plus 4, negative 2. These are your two answers. Okay, B, I want you to try this one on your own. We have absolute value of x minus 1 equals 4. Pause the video and solve this one. Okay, first step, we see that our c is positive. Whenever the c is positive, our first step is isolate. So we want to get our absolute value bars by themselves. If you'll notice, there's nothing on the left side of the equation except for the absolute value bars. So we have x minus 1 equals 4. Second step is separate. We have x minus 1 equals 4, or x minus 1 equals negative 4. Last step is to solve. In order to get rid of this 1, we're going to have to add it to both sides. These will cancel, and I get x equals 5. On my second equation, I'll add 1 to both sides. These will cancel, and I get x equals negative 3. These are your two answers. Now, I didn't show you how to graph on the first one, but here I'll show you now. Here's your number line. Now, again, on the number line, I usually like to have 0 on there just so I know where I stand. The only other two numbers you really need on your number line are your x's. So 1, 2, 3, this is negative 3. 1, 2, 3, 4, 5. Here's positive 5. In order to graph these, it's really simple. You just put a dot above it. That's basically it. All right, one more I want you to try on your own. Absolute value of 3x plus 1 equals negative 5. Pause the video, come up with an answer, and then come back and check it. Okay, our first step always is to isolate, meaning we want to get the absolute value bars alone. They're already alone, so my isolation stage is already being taken care of. So I have absolute value bars equal to a negative number. Can I have that? Hopefully you said no. This is negative. Therefore, I have no solution. So remember, absolute value is a distance. It can never be negative. This is no solution. Make yourself a little note down here. You must do the isolation stage before you can tell me that there's no solution or if there are two solutions. So note, you must isolate before deciding number of solutions. Really, really important. You have to isolate those absolute value bars before we can say that there's no solution or that there's more than one. One other thought. What if we have absolute value of x minus 1 equal to 0? We know that the first step is always isolation. The absolute value bars are already isolated. So my separate stage, we're going to have x minus 1 equals 0, or what? Can you have positive and negative 0? Basically here, you'll only have one answer. So if you have absolute value bars equal to 0, you can't split them because you can't have positive and negative 0. You're only going to have one solution in this instance. All right, a few more problems to work here. Absolute value of 3x plus 9 minus 10 equals negative 4. So remember our steps. Isolate, separate, solve. Really important. Isolate, meaning get the absolute value bars by themselves. If you'll notice, they are not currently by themselves because we have this negative 10 here. So our isolate stage means we got to get rid of that negative 10. So we'll add 10 to both sides. This gives me absolute value of 3x plus 9 equals 10 minus 4, which is 6. Now the absolute value bars are isolated. My second stage is separate. Separate, we have 3x plus 9 equals 6, or 3x plus 9 equals negative 6. Last step is to solve. We're going to get x by itself. So we'll subtract 9 from both sides. Nines cancel. And I have 3x equals 6 minus 9, which is negative 3. Still getting x by itself, I have to divide both sides by 3. The 3's on the left side cancel, leaving me with just x. X equals negative 3 divided by 3 is negative 1. Solving my second equation, we want to get x by itself. That means we need to move everything away from it. Getting rid of this 9, I'll subtract 9 from both sides. The 9's cancel. I have 3x equals negative 6 minus 9, negative 15. Dividing both sides by 3 so I can finally get x by itself. The 3's cancel. X equals negative 5. Okay, here's another example I want you to attempt on your own. Absolute value of 3x minus 6 minus 9 equals negative 3. Pause this video, use this example to help you complete this problem, then come back and see if you got it correct. Alright, solving this problem, our first step is isolate. That means we need to get the absolute value bars by itself. To isolate, we're going to have to get rid of this 9. Adding the 9 to both sides, I get absolute value of 3x minus 6 equals 9 minus 3, positive 6. Next stage, separate. I have 3x minus 6 equals 6, or 3x minus 6 equals negative 6. Okay, last stage is to solve. I'm trying to get x by itself. So to get my 6 to move to the other side, I'll need to add 6 to both sides. These guys cancel. I get 3x equals 12. Dividing both sides by 3. The 3's on the left cancel. And I get x equals 12 divided by 3 is 4. Don't forget to solve your second problem. Getting rid of my 6, I'll need to add 6 to both sides. That'll make these guys cancel. I get 3x equals negative 6 plus 6, 0. Dividing both sides by 3. My 3's cancel. 0 divided by 3 is 0. Your two answers, x equals 4 and x equals 0. Okay. Negative 3 times the absolute value of 1 minus 2/3 v, closed absolute value, equals negative 9. Okay, don't forget your steps. First step, isolate. Well, this time, the thing that's keeping my absolute values from being by itself is this negative 3. And it's negative 3 times the absolute value. So in order to get rid of this negative 3, I'll have to divide both sides by negative 3. The negative 3's on the left will cancel. And I have absolute value of 1 minus 2/3 v equals negative 9 divided by negative 3 is positive 3. Now our absolute value bars are isolated. We're going to have to separate. In order to separate, we'll do 1 minus 2/3 v equals 3, or 1 minus 2/3 v equals negative 3. From this point, we're just getting v by itself. First thing, get rid of this 1. Whoop, I don't know why I wrote that in yellow, sorry. Subtract 1 from both sides. That'll make these guys cancel. And I have negative 2/3 v equals 3 minus 1 is 2. Now, to get rid of a 2/3, a way we get rid of a fraction is we can either divide by the fraction, or there's another trick where you multiply by the reciprocal. Remember, the reciprocal is just the flip version, so we'll multiply by negative 3/2 instead. And whatever you do to one side, you got to do to the other. On the left side, the 3/2 and the 2/3, that causes them to cancel. That's the purpose of doing it. So we get v equals 2 times negative 3/2. You can plug that in your calculator if you want. Your answer, negative 3. Okay, same thing on the right side. I want you to go ahead and finish that and then come back and see if you got the answer correct. So we'll subtract 1 from both sides. 1's cancel. I get negative 2/3. V equals negative 3 minus 1 is negative 4. Now remember, to get rid of the fraction, we're going to multiply by the reciprocal, which is going to be negative 3/2 again. On the left side, the negative 3/2 and the negative 2/3, those cancel. Again, that's the purpose of doing it. And we get v by itself. Negative 4 times negative 3/2 is positive 6. All right, moving on to writing absolute value equations. This is part G. Here's how we do it. X minus the halfway point equals distance to the halfway point. This is a formula that you're going to want to know. I would probably bubble it, put a box around it, something to point it out to yourself that it's there and that you need it. Couple of random thoughts here. The halfway point, sometimes it will be referred to as the mean. And then your distance to the halfway point can sometimes be referred to as deviation. Well, I'll write those down because you're probably going to see that on your homework. All right, this is a word problem, so you're going to want to write this down. In a cheerleading competition, the minimum length of a routine is 4 minutes. The max is 5. Write an absolute value equation that represents this. All right, so what we're going to need in order to write the equation is the halfway point, and we're also going to need the distance to the halfway point. So in order to find the halfway point, we're going to need another formula. Halfway point is just A plus B divided by 2. bubble that, you're going to want it. Okay, so for this particular problem, my halfway point is A, they said was 4 minutes, plus the maximum, which is 5 minutes, and we're going to divide that by 2. So this is the same thing as 9 over 2. If you put that in your calculator, it's 4.5. If you think about this logically, I hope that you would know that the middle of A and B would be 4.5. Let's put this on a number line. So we know the minimum is 4 minutes, the maximum is 5 minutes, the halfway point, the one in the middle, is 4.5. The other thing we're going to need to write this equation is the distance to the halfway point. Here's my halfway point. What's the distance in either direction? It can be to the maximum or the minimum. It doesn't matter. They're the same distance. So how far is it from 4.5 to 5? 0.5. That is your distance. Writing your final equation, absolute value of x minus the halfway point. We found the halfway point, it was 4.5, equals the distance to the halfway point. We found that. The distance to the halfway point is 0.5. There's your answer. So again, in writing these equations, all you need is the halfway point and then the distance to the halfway point. Here's your equation for halfway point. And then finding the distance is merely the distance from the halfway point to the maximum or the minimum, either way you want to look at it. Also back here on this equation that I gave you, I did not put those absolute value bars. Make sure you put that in there. That's part of the equation. All right, one more problem I'm going to have you do. This is EFGH. So we're going to graph this without solving. Here's the equation. Absolute value of x minus 4 equals 2. So basically what I'm wanting is a graph that looks like this for this equation. So looking at our absolute value, these two things, we already have the halfway point and the distance to the halfway point. X is minus the halfway point, so this guy right here, that is your halfway point. And then this guy is the distance to your halfway point. So in order to give ourselves a graph, well, we need a number line. We know the halfway point. It's 4. And the distance to the halfway point is 2. So that means from the halfway point to the maximum, this distance is 2. Also, from the halfway point to the minimum, the distance is 2. So our number, 4 minus 2 is 2. 4 plus 2 is 6. All right, that concludes 1.4 day 1. You may now start on your homework or classwork or whatever has been assigned. If you have any questions or if you are confused, please go back and review these again.